So chefina and swap. In this, what we have to do is you are given a positive integer n and consider the sequence 1 to n. You need to choose two elements of the sequence and swap them. A swap is nice. So swap is nice if for any integer m that the sum of first m elements is equal to the remaining elements. Sum of remaining elements. So basically, sum of first m elements is half. Right. So that is what we want to do here. Alright, so question statement is quite simple. Let's look at an example. So for 1, 2, 3. So for 3, the answer is 2. Let's see how. So suppose we are looking at elements from 1 to 3 only, and how many swaps are possible. So if you swap 1 and 2, right? So let's look at the total sum. So we have to achieve, so there should be some m for which the sum of first m elements is equal to half. So total sum is 6 if we are looking at 1 to 3 only, and half is 3. So if we swap 1 and 2, then actually it's a good swap, because sum of first two elements will again be 3. So if we look at swapping 3 and 1, then also the sum of first element will be 3, which is half of total, right? So sum of 3 will be equal to remaining elements, which will be 2 and 1. So 1, 2 and 3. So two good swaps are this one and this one, right? So that's how you can explain the problem. How did I solve it? Right, so there are two cases. First is you are able to so first case is when the sum itself is odd. For example, if you write sum from 1 to n, right? So sum can be 1, 3, 6, 10. So if it is odd, then it is never possible. So you just return 0. In that case, there is no possibility of any swap making that sum equal. So that's done. So if it is even, is it always possible? That is one thing, and that we have to check, right? And how to do it. So how many swaps are there? So first thing is, so suppose the total sum was in 1 to 3, the case was 6, and there is actually a number in between. So if we look here, that there is a number 3, so basically which is actually half. So there can be a case where we actually find a number which is so the sum of a prefix is actually equal to half. So that case looks like this. So there are some x elements whose sum is equal to remaining elements without any swap. In this case, what you can do is you can swap any two elements here and any two elements here, right? It will always give you a valid or a good swap, right? Because it is already equal and we are swapping in that zone. So that means that you can swap anything. So how many swaps are possible here? It is n. So it is xc2, right? So you can choose any two and just swap them, and similarly for n minus xc2, and then you multiply them. So that will be one. So those will be good swaps for this case, right? There are other cases as well. For example, if you do that exercise here in 1 to 3, so this will be the partition. Here it is 2, here it is 1. So 2c2 will be equal to actually 1, and 1c1 will be 1, and if you multiply them you will get 1, but it is only 1. So there is one more swap which we have not considered, which is 3, 1. So let's talk about how we find that swap, right? So first thing is we have to find this partition. So how do we find this partition is implementation. Basically you find the total sum, which is 28. For example, we are now looking at the case of 7. Then the total sum is 28. Where will be the partition? So I'm assuming that I will make the partition after the number which is equal to or less than. So in this case we don't have a 14, so I will make it after 10, right? So we need to find out this number somehow. So that is implementation. You can look at, you can try to do it on your own. How do we find this number? So we have to, for given the sum is 28, I have to find 4, right? So something like that. So now if I have found this partition, right, so now what I do is I know that around this partition sum is not equal, but can I do some swap across this partition so that I can make it equal? So one thing is I can't swap on one side of partition. That will not give me a good swap, because I already know that sum is not equal, right? So if the sum is equal, then I can't partition across the wall. I can't swap across the partition. Why? Because if both of these were equal earlier and I'm putting some unequal numbers here and there, so suppose I pick up a from here and I pick up b from here, the sum of this will decrease by a and then increase by b. It can be positive, negative, and the sum here will decrease by b and increase by a, right? So because a and b are not equal, so the sum, here the sum will increase or here it will decrease, but because left is smaller, so this will increase and this will decrease, something like that, right? So if sum is equal, so basically if the at partition prefix is equal to suffix, then we can't swap across it. So for that case, we handled this case xc2 into n minus xc2. So that is done. But when it is not equal, so we know that we don't need to consider swaps alone in this region and alone in this region. So the swaps will only be across this region. So how many swaps can be there? So that is what we have to count. Now, so the diff of this prefix from the achieve sum which we want to achieve, which is 14. So because the total sum is 28, sum of prefix is 14. Now if I want to make this prefix 14, then I am short by 4. So as you see here, that if I take b from this right side and a from right side, this side's sum will increase by b minus a, right? B minus a. So that is what. So let me clear it a little bit. So if I pick b from here and a from here, then it will increase by b minus a. So I need to find out how many elements are there whose difference is 4, right? So if you check, there is 5 and 1, 6 and 2, 7 and 3, right? So something like that. So if I take these 3 elements, then I'm done. So this is it. So that is what we want to do, right? So answer for this will be 3, but there is some more things which we need to take care of. So suppose I move this partition towards left. I need to check, can I again swap across this partition? Then I need to move it left, and then again I need to move left, right? So this is what we need to also do. And I think if I put it here, so the difference here is, so I'm 1 up. So I did not go up because so I have to find any element here whose difference was 1. So I am 1 up. Okay, cool. So if I am moving elements across these partition, then what happens is on the left the sum will always increase. If I'm already up, then I don't want to increase, right? That's why I will not look at the partitions on the right side. I will only look at partitions on the left side, right? So that's it. So we found the first partition where the sum was just smaller or equal to the half. Then I move this partition to the left. So for this partition, the answer was 3, because I can swap 5 with 1, 6 with 2, and 7 with 3. So now if I take my partition here, let's say, right? So let me clean up as much as I can, right? So suppose I take my partition here now. Now what is the sum? The sum is 6, and half was 14. So 14 minus 6 is actually equal to 8. And I can never make a 8 because the numbers are from 1 to 7, and the maximum difference which I can achieve is 6. So this was increasing by b by a, right? So this side, left side, can only increase by at max 6. So that's why, so the difference here is now minus 8, right? So that's why now basically it means that I can't swap anything here, because it is not possible, because the difference is 8 and the maximum I can achieve is 6. So if I go here, then the difference will actually increase, which will be minus 11. So this sum is 3 and the half is 14. So what you can see is we have moving partitions towards left side. We have to put a limit on it. So how many partitions you can move? You can't move so many, because at each, so the difference will be half will be in. So you can do some calculations here that you will not be moving much, because every time you are actually decreasing 4 then 3, so you are decreasing in linear way, and so you will not make many moves here. So you can put a limit on that as well, right? So you will be looking at some of the partitions here, and what we are doing is we are looking at a partition and we are seeing how many swaps are possible across this. For example, across this there were 3, across this there were only 0. So 3 plus 0, 3 only, right? And because it did not have this case where both sides were equal, we don't need to do this combination multiplication. So that's it. So that is what we need to do. So now we need to relook at 1 to 3, because it has both the cases where we have to shift the partition as well. So first I see that partition is here and I see that it is equal, so I do nc2 into n minus xc2, which will give me 1. Now I see that I can shift partition here. The sum was 6, but the sum till here is 1. So the difference is 3 minus 1. So total sum is 6, half is 3, and difference is 2. So the difference is minus 2. So I am 2 less. So so this is the partition I'm looking at. So can I find any number which is 2 bigger than me? Yes, I can find. So I swap it. So that next one comes from here. So this one plus this one will give me 2. Right? So that's how. So basically I need to first find the partition. If both sides are equal, then I do this combination multiplication. Otherwise I find how many swaps I can do, right? For example, here I can swap 1 with 3 only. So that you need to figure out how to do that. So I will just quickly show my code how I did it, and then there might be some implementation difference. So first I found triangular number, which is like the sum of all the numbers. So that is done. If it is odd, then nothing. Then I find half of it. For example, in this case, 28, half was 14. So I find half and then find the closest triangular number to that half. So I mean, like I have implemented it with the parameter tr, but it will actually find the closest triangular number to half. So basically it will give me 10 or 4, something like that. So it will give me where the partition is. Then I find that triangular number, which will give me 10 actually. This one. So x will, I think, give me 4, and this thing will give me 10. So now I have htr is half triangular number, or triangular number which is near to half is 10, right? Now I just see if htr is equal to half, for example in this case. So that htr will be 3 and half will be 3, so they both are equal, right? If they both are equal, then I need to do that combination thing. So x into x minus 1 divided by 2, which is nc2, and then how many are remaining? N minus x, and then I do that, and then then I'm adding them individually. Oh, in one move you can only do one. Oh, then my calculations were wrong. So 2c2 and 1c2. Oh, this will be 0. So it was actually 1 plus 0. My bad. Because you can do only one swap at a time, then it will be added, not multiplied. Alright, so something like that. My bad. So that is it. So that is the case when both halves were equal, right? So that's what we have to do. Then after that I'm doing that diff thing, and if I'm trying to doing some, I mean, I did not do too much calculation, and I was able to find how many swaps it will be possible across the partition, and then you can try to implement it. For example, in this case, if partition is here and diff is this much, then you need to figure out that you can do only one swap. But if the diff was 4, then you can do actually 3 swaps, 1 to 3 to 5 to 7, right? Something like that. So that I calculated, and then I move the partition 1 left, right? Here also I'm moving that partition 1 left, right? So that's it. So that's how I implemented this question.